Welcome back. Here's the second half of the video for the experiment that you'll be doing to turn in for me next week. Yes, next week. The earlier one on the computer, that was what they call the quantitative. So you would actually work with numbers. This one here is a qualitative experiment, where basically we're just looking at inputs and outputs. What happens initially and what happened afterwards, strictly just by motion. So I'll be working with these here carts, and in a separate video after this one, I'll be explaining the form that we'll be using. Like I said, it's going to have all 16 scenarios pre-put into it, and I'm basically going to show you the first one, and you'll have to fill in the second ones for 1, 2 through 15. Okay. So each scenario is described in the lab manual. The first one is elastic mass, equal carts, equal masses. Yeah, they feel about the same. And it says one cart in the middle, and the other cart is pushed into it. So the thing you're going to look for is basically how fast this guy is going initially. This one's not moving. After impact, essentially what's this cart doing and what is this cart doing. So right now, this guy I'll be imparting a certain velocity into him. He'll hit this guy. This would be a fully elastic collision. So let's see what happens. Excitement, I think. The moving car hit the stopped car. He basically stopped, and the other one took off. The question is, compared to how fast he was going, how fast was this one going after the impact? Do a few times. Hopefully what I'm seeing is it's going about the same speed. How fast he was going, the energy got transferred to this one, and all the speed was transferred from one to the other. So on the form, elastic mass equal, one cart pushed into the other cart. So equal masses, that's why they're the same size. He's going at zero velocity. He's going at a relatively good velocity. After impact, what happens? Well, this one went to zero, and this one basically took off at the same speed. And that's basically what we're going to be doing for the next 15 ones. So the next one, we're going to have equal masses. It will be elastic. And now we're going to start both at opposite end and have them hit in the middle. Let's see what happens. Hopefully I can get rid of these same speeds. A little adjustment here. Do a few runs. Well, I'm not going to describe anything anymore. I'm just going to do the runs, and you all have to figure out how to describe it. So both on each end, elastic, come together. And what happened? I'll go on the arrows And this one describes what happens by arrows. Next one, equal mass. One guy going slow, the other guy's going fast. Let's see what happens. My table here. Going slow, fast. Slow, fast. Slow, fast. Thing you should be looking at is how do the relative motions between the two masses change? Slow, fast. So now at the end, who's slow, who's fast? Next one. Ooh. Big block. That means I'm going to take these extra masses, put it on here, and make him much more massive compared to this guy. Okay, he's going to be stopped. And I'll drive him in. Now I have him do a fender bender, rear end him. Interesting. Okay. Stopped. Going fast. How they go at the end? Stopped. Fast. Relative motion. How fast? What direction is this one moving? And how fast relative to this guy in the beginning? At the end, which way is this one moving? And relatively how fast comparison to the initial run. Put the arrows in appropriately. Okay. Next run. All right, the big guy, the big mass, smaller mass, both coming towards each other at about the same speed. Try it again. Again, what to look at between the beginning and ending is, again, relative directions and arrow sizes. One last one. Okay, now let's see. Next one. Still 3-1. The big one's going to be going slow, and the small one be going fast, and then overtaking. Going slow. Fast. Going slow. Fast. Going slow. Fast. Slow. Fast overtaking. So again, from the relative motions, put the appropriate arrow sizes. Let's reverse it. The heavy guy going fast, overtaking the light little guy. Slow, fast. Slow, fast. Slow, fast overtaken. Okay. So be looking at this one's going slow, this one's going fast. After impact, how fast is this guy going? In what direction? And relative compare starting speed, how fast he's going, and in what direction. Whew. Okay. That's the elastic. Inelastic. that means is now we're going to have a little sticking action going on here. But basically, exact